Finally, we are going to talk about the pallets inside the substrate. Pretty interesting topic, and now more and more documentation is getting available, so this one is just an overview. So in order to start with this, we need to set up Substrate node, Rust, and the front-end UI. So one of the best ways to do it is using the Substrate portal. Oh yeah, I think this is the different one. Yep, that's it. I'm going to share the link in the comments. And what you just have to do is, again, you have to install the Rust, you have to install the node, you have to clone the template, which is here. Then you have to build. It's going to take some time. And then also you need to clone the UI for the project, because UI is how you're interacting with your node. And once you're ready, you can start your local node. You're basically just running node template in a dev environment. And the next one, as you can see in my terminal, it's running already on my left side. And then you have to go to your directory with the UI and just run yarn start, and it's going to start your UI, which will automatically connect to your running blockchain node. So once you have done that, you can see something like this once you have done that. So you will see the full information about your node, what's the location, port, metadata, block, finalized block, balances, which is something which is already pre-deployed with the node just for convenience, so that you can basically play around with the well-known accounts, Alice, Bob, etc. And you have something that we are going to concentrate today, which is called Pallet Interactor. So Pallet Interactor, this is how you are going to interact with your pallet. So since this piece is just a tutorial, again, you have to follow all of the previous steps. Now we will just talk about the pallet. So the entire substrate is built from these modular blocks that are called pallets. And believe it or not, even the staking is also a pallet. There is a beautiful diagram somewhere here. I think, yeah, okay, it's here. So I'm going again to post this link, but as you can see, that's all of the pallets, they basically provide the functionality. So you have consensus mechanisms, you have some EVM pallets, you have staking, you have balances, everything. And it basically forms what's the blockchain node by itself is, all of the functionality. And at some point you will have to create your own pallet just for particular use case. So just say you have your own logic for staking or something like that. And in this tutorial, this is just the first part. We are going to have a look at some of the example pallets that are already provided within the node project itself. So if you clone the project and then you run the node, open it with your ID of choice. It could be, again, in my case, it is IntelliJ. You can use something else, and you will see that this is the root of the Substrate node template. So as you can see, we have a node with all of the main logic, and then we have a pallets. So the thing is, in this best part about this project is that it already comes with a test palette, which is called template palette, that provides some of the common functionality. So let's go through it real quick. This palette, again, we are going to ignore some of the mock tests and benchmarkings. This is something that you can look for yourself. But we are declaring here the palette. Again, we are using a bunch of macros, etc., and annotations. So we are going to look exactly what does it do. So we declare the palette, and then we provide the configuration for the event. So as you can see, it's self-explanatory. It says that since our palette emits events, we need to depend on the definition of the runtimes of event. So at the next stage, we declare the store, And then the most important part is we declare a storage. So here we are using the storage value. Storage value is something which is already integrated in a frame support libraries. As you can see, it's here. So we have a value, we have type, and if you go back, in our cases again, it's nothing is stored here, and then the type of our storage is unsigned integer 32. The next one is we declare a couple of events. So one event is again something stored, and another is the error when we can have storage overflow or non-value. So if you look at this code of the template palette, you're going to see lots of comments. So if you're getting stuck, it will help you. And finally, we are getting to the most interesting part, which is the calls. So we can call that these functions at some point they can be called as extrinsics, which means that again we may submit the transactions for that. So if you want to mutate our store, so we have two functions. We have do something, and then we have a function cause error. So if you look at the do something function, so what we are doing is that we are checking who calls this function. So the origin is, as I believe, this is the address which is calling this function. Then we are putting something, and this is something. It's something that we are going to also supply to our extrinsic call. In a minute, I'm going to show you. And the next one is we are using deposit event. An event is basically something stored. So again, we are mutating our storage, and then we are exposing event. We are just publishing event that something is stored and by whom. And then we are returning OK status in the end of the function. So let's just look at this function just for now. Now the question is, how do you call this function? So if you go back to your UI for the Substrate node, which is once you started, it should be on your localhost 8000. You will see the palette interactor. So, and if you click here, you see all of your palettes. So as you can see, you have a palette for balances, some other internal tools, system, and then you see a template module. So one of your questions would be, how do we even use this palette? How do we expose it? And the reason why it's visible there is that we need to include this palette in the runtime. So the way it's included in the runtime, as you can see, we have a folder runtime. And if you go to the cargo toml, you'll see that we include this palette as a dependency. So you can see line number 15, dependencies palette template. We are providing the path for our template, which is here, palettes template. So this is kind of inclusion of internal library in our project, and this is how we are importing it. And since we have a dependency for our palette within our runtime, we also need to put it inside our runtime environment. So if you go to the lead.rs, which is basically which has some logic for the construction of the runtime. So this is construct runtime macro, and as you can see at this line 296, we are including palette runtime. Palette template. And this is how our palette template is going to be included within our node. And if you go back to the UI for the node project, now we can have some test whether it's going to work or not. So first of all, we have different interaction types. So we have JSON. We have RPC calls, so yeah, we just say, okay, hold on, system payment. Okay, that's fine. So RPC, it's again just a normal. It's just a normal call. It's just the socket query. You don't need to sign the transaction. Same with the normal query. I think the RPC and query is the same. I could be mistaken, but if you put, let's say, template module, so you're just selecting the palette, and then callables would be something. So the idea is we are querying what's the state of our storage. So what is something? If you go back to our palette, so if you go to palette template, and then let's go to our lib.rs, and we scroll a bit up. So as you can see, line number 36, this is where we declare our storage. This annotation generates the definition of our value. So here is, of course, it's just a type, but it generates the value of something. And something is basically a holder of our value. When we mutate that something, for instance, here something of template type, we put whatever value we have, it's going to mutate that. So if we go back to our UI and then try to query, as you can see, boom, so the result is none, right? Because at the beginning it has absolutely nothing. And if you want to put something, if you want to mutate the value, we need to call the function do something. So we click on extrinsic, then we select a template module, then we provide the callable, and again, as you remember, we have cause error and do something. We didn't look at the cause error because it's not super fun, but we look at do something. And once you click do something, you can see that this UI pops out with the input. So what is this input? If we go back in our function do something, as you can see, boom, we also accept something which is unsigned int 32. And in this case, we are passing this value, which would be value that will be a part of the storage. If we go back, and then let's say we are putting 1, 2, 3, and then we just say we are simply putting unsigned. Oh yeah, since there is a good example. So if we click unsigned, as you can see, it would actually fire the error, since we need to ensure that it's assigned, and this extrinsic should be signed. That's why it fails with the error. So let's ensure that it is signed. And as you can see, when we say signed transaction, we basically sign it with Alice account. So at the current UI, we have Alice here as a default account, but if you build your own application, of course, you would sign extrinsic with whatever account is authenticated with your Polkadot.js extension. But since it's development environment, we have Alice. So and now we just say that something is 1, 2, 3. So again, it was a success of the transaction, and I just say if you want to put the new value, you put store something, current transaction is ready, and again, kind of done. So as you can see, it overrode our 1, 2, 3 with the 777. Great, so success. And now if we are going to go to query, and now we are going to put the template module and then something, and then the query, boom. So the query returns us 777. So beautiful. The block has been finalized, storage has been mutated, and yeah, congrats. This was the first overview of the palette that modifies the Substrate storage. So you could create any other palette, since one of the examples, again, the staking is a palette. There is a palette for balance. There are palettes for other causes. And if your blockchain needs some customized logic, what you have to do is you have to start with a palette. And of course, a bit lower level than a palette is a frame. Frame is even lower than that. If you go to official documentation, frame is the lowest you can get. So again, the frame is the runtime aggregation of modularized entities, the framework, and palette goes one top higher. So you're basically building pallets with the frame, but if you want to go all the way down on the lowest level, you can start with the frame. So this was the first explanation of the pallet. Congratulations. In the next one, I'll think about the next stage. Maybe we will build some different custom pallet, not the one from example, and even wire up the UI, because I already made another YouTube video before how to wire up the UI, and what we'll have to do is just simply make the transactions that will be exposed by our new palette. So yeah, hopefully it was useful. Let me know if you have any comments, and I'm going to put all of the links in the description.